So what we want to talk about today is we actually had one of our customers ask a question, and we thought I'd make a good, quick little video here. So customer has a problem. They burn wood, and so their emissions are from wood waste. They're burning the wood, and this will work for anyone who burns lumber, burns sawdust, even some of the petrochemical products as well, because the whole point is when they burn all those, you get a lot of hydrocarbons being generated in the gas stream. And so their question was, Gary, I've got a problem with the probe because my filter is totally clean, but my sample line has all this discoloration in it. So we're going to run through this really quickly. So this is an example of a probe that they would have. So they take a look at the probe. They pull out the filter. Filter's nice and white and clean. But then they look at their sample line, example of a sample line that connects onto the unit. It's all discolored inside. Brown, starting to go black with the hydrocarbon inside. How can this be? What's the problem with my filter? There's actually nothing wrong with your filter. This is where we get into what we've talked about in previous videos about every chemical reaction requires time, temperature, and some movement. So what's happening is the hydrocarbons are still in gas phase. They haven't condensed out. They pass through the filter as a gas, and as they enter the sample line, either because of a difference in temperature, cold spot in the sample line, we start to get it condensed. So you start to get that oily film forming on the inside. That's all those hydrocarbons condensing. So remember, in all of this, we're always dealing with chemical reactions. We're always dealing with time, temperature, and some sort of movement. So by controlling those temperatures, we control where this chemical knocks out. Most important thing is you don't want to knock it out in the sample line because the sample line is one of the weakest points in the entire system.